So welcome to today's lesson on specific heat capacity. So there's 3 learning objectives for today. Know what specific heat capacity is, explain why heating a system will change the energy stored within that system and raise its temperature, and also using the equation of heat, which is delta Q equals MC delta T. So, always blow on the pie, as we say in New Zealand. Have you bitten into an apple pie and burnt your mouth? Or even a meat pie? The outside is warm, okay, the crust, but inside it is scorching hot. It was all cooked at the same time, so why is there a temperature difference from the pie crust and the pie inside? That's because the meat filling or apple filling, depending what pie it is, has a higher heat capacity than the pastry. So what does it actually mean when we say heat capacity? Well, the first thing is you've got to have an understanding of the difference between heat and temperature. So heat is basically the thermal energy inside the substance, inside that pie, whereas temperature is how fast those particles inside the pie or the pastry are moving. Okay, so here we have 2 examples of particles. On the left-hand side, you can see the particles are kind of slow moving, so they would have a lower temperature, whereas those on the right are moving faster, and therefore they would have a higher kinetic energy, and therefore the temperature would be higher. So when the heat energy is transferred into an object, then the temperature will increase because the particles inside that particular object will start to move faster. So what is specific heat capacity then when we looked at the pie? So it's basically how much energy the material can store. So it's essentially the heat energy required to raise the temperature of a substance of 1 kilogram by 1 degree Celsius. And the units are joules per kilogram per degree Celsius. So if we heated these materials for 10 minutes, which one do you think would be the hottest of copper, limestone and water? Well, after 10 minutes, the copper will be 82 degrees Celsius, the limestone would be at 65 degrees Celsius, and the water would only be at 43 degrees Celsius. So the copper was the hottest because it had the lowest specific heat capacity. It required less heat energy to raise the copper up a degree Celsius. Okay? Whereas water has the highest specific heat capacity, so more heat energy is required to be absorbed to raise it up a degree Celsius. So how do you calculate specific heat capacity? We use the equation Q equals MC delta T, where Q is the heat energy transferred in joules, because it's energy, mass is the mass of the substance that you're heating in kilograms, and delta T is a change in temperature, so from the initial temperature before you started heating to the final temperature when you have heated the object over a certain amount of time. And C is the specific heat capacity in joules per kilogram per degree Celsius, which is unique to every substance. So this is the equation rearranged. So mass equals Q divided by C times delta T. Delta T will equal Q divided by C times M, and C equals Q divided by M times delta T. So you have to be able to employ this equation to answer questions around specific heat capacity. And that is the end of today's lesson.